That's the other class I usually record to a couple of. You can't show it.
What's this for?
I put it online. It's on the,
Miss Stevens had to do one for like the state or something.
yeah. I do it for everyone. Get on Moodle, you'll see. All right, so make sure at some point you got theorems, postulates again. Page 133, 134, that's just telling you what page they're on. Go to the back of the book and copy them. It's so much easier. All right. We're going to do all of chapter 3, theorems and postulates at some point. So if you got time, get in there and do some of those at some point. We're going to go over this problem right here. Mike owns 20 Mustangs. I'm just going to write down a couple of things over here to the side, or 20 vehicles, sorry, Mike Mustang. He's got 20 vehicles. I'm just writing this down so I can switch the slide. But he's forgotten how many cars he has and how many motorcycles, so we don't know the number of cars. We don't know the number of motorcycles. I'll show you how to do this. Make sure you remember some of this from algebra. He's got a total of 66 wheels. How many motorcycles, cars does he have? So on this problem, just to help you remember some stuff from algebra, what we could do with this problem, first thing you should do, can you see that? Should I use red? Define your variables. All it means to define your variables is go through and say, all right, what things don't we know? So we don't know the number of cars. Well, we can let that be what? X, C. I'll use C since cars, that way we don't get confused at the end. And what else don't we know? Number of motorcycles, good. Now, can you just let that be C also? Because we don't know that they're the same. Now, the bad thing with this is we let it be M. Now, all of a sudden, we got two variables, and that makes everything 100 times harder. You got to do special stuff with it. So if I go to set up an equation, he's got 20 total vehicles. Well, what would you do with these two to get the total? What do you do with the motorcycles and the cars to get the total? C plus M equals the other number. 20. Cars plus motorcycles should equal 20. Bad thing with that, Kaylee, can we solve that? It's got two variables in it. What other equation can we set up? All right, now watch carefully on this one. Take 4 times C, because each car has how many wheels? 4 plus each motorcycle has how many wheels? And all the wheels should total up to be 66. Whenever you have two variables, you need two equations to be able to solve them. And what you're using is systems of equations. Guaranteed there's some of these on future tests, just like with the quadratic equations. Systems of equations, last year in algebra, you learned 3 different ways to solve them. You could graph it. You could graph, see where the two lines intersect. You probably don't want to do that. Not real easy sometimes. If you have a graphing calculator, it makes it a little easier. You could use substitution. We just talked about substitution last chapter. Substitution here would be say, all right, I know C is this, so in place of C, I can stick in whatever it is. Well, if they're both in the form that we have them in here, which is standard form, these are both in standard form, then the easiest one to do is probably elimination, and that's probably the one that most of you like when you were doing them in algebra anyway. Elimination just means you eliminate one of the variables. Now, the way I eliminate it, I also call elimination the multiplication addition method. That's how I learned it. Because you got to multiply by something, then you add them together. So, what do we do here to try to eliminate one of the variables? What would help us to eliminate the C's or the M's? How could you make the C's, let's do the C's, how could you make them the opposites of each other? What would you do to this C to get it to be opposite of the other one? Help me out, Natalie, what would you do to make this opposite of that? If this is 4C, what's going to be the opposite of 4C? What's the opposite of 4?
-4.
-4. So what would you have to do to this C to get it to be a -4? Multiply it by, since there's a 1 there right now, what do you multiply 1 by to get it to be a -4? -4. So you multiply this whole top equation by -4. As I do this, you're going to distribute the -4 out to everything in the top equation, and it gives you a new equation. What's -4 times 1C? -4C. -4 times M. -4M. -4 times 20. What's a negative times a positive? -80. Now, that's the multiplication part. What we're going to do then is the addition part. We just add them straight down. All right? What happens with the C's? That's the whole purpose. That's why it's called elimination. You get rid of one of the variables. 2M and -4M give you how much? -2M. It would work. What's nice about that new equation that we have right there? One variable in it. That's the whole purpose. How do we solve it? What's M equal? -14 divided by -2. Negative divided by negative is positive. So what's 7? So we have 7. That's why we define the variables up here. We have 7 motorcycles. Now what? How many cars how can we figure that out? No. We had a total of 20 vehicles, so 20 minus 7. What is that? We got 13 cars. Be able to do elimination. We're going to do quite a few of those throughout the year. Stuff you should have learned in algebra, stuff you're going to use next year. Also, quadratic, where you have an x squared. We're going to do a lot of those. All right, have your books open to page 128. Check page 128, so have it out.
What?
128.
I don't think I have it with me. I think it's in the disclosure thing, because that's where my test thing is. Because I was doing an intervention yesterday and I left it in there. So if you can just bring it to the intervention.
Yeah, make sure, because this will be the third one. And next one you miss is a detention.
Wait, what?
You get a free machine sign, you just did it.
You missed page, the chapter 2 review, and the puzzles the other day. This would be the third one, so make sure you bring it to me. If you don't bring it, I'll write it up,
I have my chapter 2 review with me.
then turn it in to me. I don't know why you didn't turn it.
I don't know either.
laid up there on my picture. So books open to 128. Questions, problems you want to see worked off of 128. No, everybody understood all of them?
No.
All right, Natalie. Which one? 48. Problem 48. Airplanes are heading eastbound, assigned an altitude level that is odd number of thousands of feet. Airplanes heading westbound are assigned altitude that's an even number of thousands of feet. If airplane is flying northwest at 34,000 feet, another airplane is flying east at 25,000 feet. Describe the type of lines formed by the paths of the airplanes. So if we have these two airplanes, I'm gonna move you somewhere else where you can't talk to anybody if you don't quit. All right, so get your stuff, move to that very back chair back here,
Wait, which one?
the brown one.
That one or that one?
That one.
North around.
That way you don't get yourself in trouble. So if I'm standing here, and I'll try to face this way so that I'm facing the same way as you. Usually if you're standing somewhere and you're facing which way? As far as the direction goes? North. That's what we usually think, right? Now, does that mean I'm actually facing north right now? No, I don't have a clue which direction I'm facing right now. But this is north. If I'm facing north, what's behind me? South. What's this way? East. West. So we got an airplane. Somebody help me out. What was the first airplane flying?
Was flying northwest.
Northwest. So it's going, I gotta think again. Northwest would be like this, right? So it's flying this direction. That's my airplane path. Like when you see the smoke in the sky, whatever, from an airplane. And it was at how many feet? 34,000 or 30?
4,000.
So it's up here somewhere maybe. What's the next one?
East, 25,000.
So east, that's going this way at about 25,000, so a little lower. What kind of lines do those two make with each other? Skew lines. They're not parallel to each other. They're not going to intersect. Let's hope they don't intersect, right? Because if they intersect, what's that telling you? Planes are going to hit each other, so they form skew lines. That's all you had to write down, the skew line. That big long paragraph, 4-letter word. Next question. Does that look close enough? Probably got them numbered. So I got 3 here,
4,
4, 3's here. So what's it go here?
5, 6, 7. Yeah, 7.
So it goes around it. This one do the same thing. So start with
9, 10, 11,
and this one, I'm guessing does the same
12,
thing.
13, 14.
Where is that? Can we just do 34 instead?
We're gonna do them all. 32, 2 and 10. So you're just trying to figure out what 2 and 10 are to each other. This is what I want you to do. When you're getting a picture like this, it's too hard to look at all those angles at the same time, all right? So when you're getting a picture like that, get rid of one of the lines. If we're doing 2 and 10, Which line in this picture do we not need? So let's cover it up. 2 and 10 are what special pair of angles to each other? Corresponding. So 2 and 10 would be corresponding, because if we shove those lines together, they would overlap each other. All right? Next one, 1 and 11. 1, 11. Again, we don't need this line to make those two angles. 1 and 11 are what kind of angles to each other? Those pairs that we talked about last time. Alternate exterior. They're both on the outside. Good. Both on the outside, and they're on alternate sides. Next one is 5 and 3. 5 and 3, which line don't we need for 5 and 3? So we get rid of that. What are 5 and 3 to each other? Alternate interior. And remember, if you trace alternate interior angles, what should they form? A Z or an N or a lightning bolt or whatever you want to call it. That'll help you remember it, hopefully. What's the next one? 8 and 3. Let's try to run through this sort of quick. 8 and 3, same opposite. Get rid of the same line. What are they? Consecutive interior angles, or I think, did I tell you guys that sometimes I'll screw up and call them same side interior angles? All right, so maybe same side interior angles. I like that name better because they're on the same side of the transversal and they're both interior. Makes a little more sense. Next one, 9 and 4, is that right?
That's 39.
39. Did I miss one? 9 and 4. What are 9 and 4? We get rid of that. Same as last one, isn't it? Consecutive interior angles. Is that all of them? Did I do all of them, or did I miss a couple of them? Oh, we only did the even numbers. I just did all of them. Other questions?
Okay, like on the outside, like 12, 11, 16, and 15,
Let's just look at one pair at a time. 12 and 11.
isn't that exceeding?
Yep. But
What about 11 though?
what are they to each other? They're adjacent to each other, and they're also, what's a better name that'll help us more with the math? They're a linear pair, they're supplementary.
Okay,
Right.
What about 11? It's on the inside and outside.
It's on that, well, it depends on what you're dealing with, and that's why if we're looking at those two together, we just want to say that they're supplementary. We don't want to give them one of those other special names. All right? Now, if you want to put 11 with another one, so give me 11 and another angle that you want to pair it up with. 16. So now we want to get rid of this line up here, right? Now you're right, 11 and 16 are inside.
So it's just depending on like what angle you put it up with.
All right. Well, sort of. It depends on how you're looking at it, because if we want to deal with 11 and 1, that means we're getting rid of this line. We don't want this line in our picture. Now 11's an exterior angle because where it's at. See, 11 is on the inside of these two lines, but it's on the outside of these two. That's why we don't want to look at all 4 lines at the same time. You want to split it off. So sometimes when you're doing, like if you're doing a problem on the next test that we take and it has something like this on it, and you see this picture and you say, all right, I want to deal with angle 1 and angle 7, then my suggestion to you is going to be to split it off and just look at the lines you need to look at for angle 1 and angle 7, and don't even draw in that bottom line, because it's confusing if you do. And that's going to make it easier, because then you look at this and say, oh, they're both exterior angles on alternate sides. Where 7, if we drew this line in here, 7 for these two lines would be a interior angle, and we don't want that. So it depends where you match it up at and stuff. Other questions? Make any sense? Sorry, I shouldn't have. I seemed to look like you were understanding it, so I drew that line in. Forget that line. Split things off.
What's 7? 7, it looks like it's
It is an exterior for
Then
those,
why didn't you just say interior?
because now watch what happens if I do this. I draw this line, and then I use this as my transversal. 7 is right there. 7 is what kind of angle for those two lines?
So it looks like it's two.
Is it, remember, it's between the two coplanar lines. So that's the interior, then the exterior is stuff on the outside. Other questions?
We're not in science.
All right, go ahead and start copying this down. Today is the 1st. Today is the 1st.
What are you, our grids in for like homework and stuff?
For what?
Our grids in for homework and stuff?
Most of them should be in there except for, I think for you guys, I think I even got quizzes in there and,
I can tell you what it is. In my consent.
all right, what we're going to cover today, using properties of parallel lines to find angle measures. So this is going to deal with the same stuff that we dealt with last time, dealing with those special angles, except we're going to actually say, all right, we know these lines are parallel, then we're going to know special things about those angles. Just like we know vertical angles. What do you know about vertical angles? If I give you two angles and tell you they're vertical, you know that they are what? That's true, but what do you know about their measures? They're congruent. What do you know about supplementary angles? Those are the ones that add up to 180. So we know all that stuff already. We're going to deal with those special pairs that we talked about. The same side interior, I'm sorry, the consecutive interior, corresponding, alternate interior, alternate exterior, all that stuff that we talked about last time. Be able to identify those special pairs of angles, be able to set up equations and solve them. So we're going to do a lot of setting up equations. They're going to tell you this angle is 5x minus 2, this angle is 8x plus 3, and you got to know whether you're setting them equal to each other or if you're setting them up this plus this equals 180. All right, just write this down, skip a line or so in between each one. Oh no, but this is your note. We're going to write my explanation of them. So that way, because did you understand them when you wrote them down in the?
I didn't comprehend them.
That's why we put this.
I don't comprehend anything.
So that's why I want to explain it to you, and then you can say, oh, okay, now I understand it.
Can I just listen?
Why the first one's a postulate, I'm not sure why, and the rest of them are theorems. This book does it that way.
Why does it matter?
It doesn't really. Just a postulate's something that we just take for granted is true, and the others are something that would have to be proven to be true. And I'm not sure why this one doesn't have to be proven. I think in other books I've done, it's always been a theorem. So it doesn't really make a whole lot of difference. All right, postulate 3.1 deals with corresponding angles, and this is what it says.
We leave here for girls. Yeah, we can have a second.
What is it?
Wait, what?
Let's switch back the pen on it.
Freshman, you have a second one.
Oh, never mind.
So if we have postulate 3.1, if I draw a picture over here, we know that these two lines are parallel, and I'm going to give you a shortened form of these theorems so that you can use them when you're proving this stuff. Just give these some numbers here. We know that these two lines are parallel to each other. Postulate 3.1 tells us about corresponding angles, and it says if parallel lines, then corresponding angles have to be congruent. So that's just a shortened form. So if they want you to say, tell them why these angles are congruent, then you can write that shortened form instead of writing out that whole theorem. So if you have parallel lines, then you know that corresponding angles are congruent. Tell me a pair of corresponding angles over here. Bailey, give me a pair of corresponding angles in that picture. Congruent. Then they are congruent. Remember, with corresponding angles, you take the two lines, shove them together, not fold them or anything, just shove them together, and they should overlap each other. 2 and 5. So angle 2 and 5, we know angle 2 has to be congruent to angle 5. Angle 3 has to be congruent to what? 7. And are there others in there? Yeah. All right, so that's for corresponding angles. If the lines are parallel, then you know corresponding angles have to be congruent. The next one's alternate interior angles. It says, and these are going to look real similar to each other, if parallel lines, so if you know the two lines are parallel, then let's just look at them. Name me a pair of alternate interior angles. 5 and 4. What looks to be true about 5 and 4? They look the same? Sort of hard to tell, right? Since my drawing's not very good. But that's what it's going to end up being. Then alternate interior angles. I don't know why I put the word R in there. Alternate interior angles congruent. So if the two lines are parallel, alternate interior angles are congruent. Let's get rid of that. Wasn't written very well here. So what do we know about angle 5 and angle 4 here? They're congruent. What do we know about angle 3 and angle 6? They're congruent. What do we know about angle 1 and angle 3? They're congruent because what kind of angles were they? They're vertical angles. We knew that already, right? What do we know about angle 1 and angle 2? They're a linear pair. They're supplementary because they make a line. So don't forget all that other stuff that you already know. That still all applies to this. 1 and 2 are supplementary. 8 and 7 are supplementary. 6 and 8 are supplementary. 8 and 5 are congruent because they're vertical. You know all that stuff already. Theorem 3.2. Let's do this. I'm going to move 3.2 down to here because I don't like it. Theorem 3.3 deals with alternate exterior angles. Says if you have parallel lines, so if you know the two lines are parallel, then guess what's true about alternate exterior angles? What looks to be true about what? Give me a pair of alternate exterior angles. 1 and 7. What looks to be true about those two? Jason, what looks to be true about 1 and 7?
They are.
So then alternate exterior angles. So again, a shortened form. It's parallel. If you know you have parallel lines, that's what you're starting with. Remember, the if is your given information. So we're given that we have parallel lines. Alternate exterior angles must be congruent. Theorem 3-4. Now let's jump back to 3-2 real quick. On theorem 3-2, the reason I separated it from the others, it deals with consecutive interior angles. If 4 and 5 are alternate interior angles and they're congruent to each other, 4 and 6 are consecutive interior angles, are they going to be able to be congruent to each other? No. So guess what they are to each other? Angles can't be parallel. Lines are parallel. What's the other thing that, what's the other thing, what's the other word that we use instead of congruent? What goes along with that sort of when we're trying to find the measure of something? You guys told it to me earlier. What'd you know about, let's do this. We know 4 is congruent to 5. We know that's true, right?
Yeah.
What do you know about angle 4 and angle 3? They add up to be 180. They're supplementary. All right. What do you know about angle 5 and angle 6? They have to be supplementary. Now look at what we have here. We know 4 is supplementary to 3. 4 and 5 are congruent. Well, what's going to have to be true about 4 and 6? They're supplementary. Consecutive interior angles have to be supplementary. So it's different than these other 3 that we covered, because on all these, if you had parallel lines, then what do you know about the pairs of angles? They were congruent. This one says, if you have parallel lines, then consecutive interior angles are supplementary. That's the only one that's different. And again, I like to call them same side interior angles because that helps me remember the same side with the S's. That helps me remember supplementary. Three, 4. So if lines are on 3-2, if lines are parallel, consecutive interior angles are supplementary. I'm going to erase some of
When I
this.
say congruent interior angles,
Where at?
I think it's next one, consecutive.
This one?
No, at the very bottom. The
It's
3-2.
consecutive. Sorry, I got you. I try to consecutive interior angles. Try to abbreviate as much as possible. Do what?
Hey.
Put a period there. Consecutive interior
Sew
angles.
it.
So if it confuses you, then write it out a little more, right? Maybe write COSEC or something. Consec. You wrote it out. That might, for your notes, that might be the best thing, so when you're reading back over it, right? On 3-4. Going back to 3-4, this is it's called the perpendicular.
You got,
You want me to go back?
yeah, looking at all the bottom of that.
I'll rewrite it up for you.
I have it, parallel lines are consecutive interior angles.
I'll tell you. Perpendicular transversal theorem. And all it says, they are supplementary. If these 2 lines are parallel to each other, those 2 lines are parallel to each other, and we have a transversal, and you know one of those angles is a right angle, guess what has to be true about all other 7 angles? They're all right angles. So if one parallel line is perpendicular to the transversal, then the other parallel line has to be perpendicular to it. And we know all these are right angles, all these are right angles. So that's what theorem 3.4 says. It's called the perpendicular transversal theorem. So if you know you have one right angle there and the two lines are parallel, then all the angles are going to be right angles. So if you wanted to write it out like the other one, we'd say if parallel lines and maybe any angle is 90 degrees or a right angle, then all the angles are 90. That's not really a good way to write it, but maybe that'll help you remember.
No, not really.
All right, write this down, draw the picture. When you write down this bottom part, I'll turn the light on here in a second. When you write down this bottom part, you might want to skip a line in between each one. We're going to name all the special angles on those two, or on those, in that diagram.
Instruction as a fact teacher to take way back to their classrooms, and now we can ask for juniors. Junior Dr. Gently.
All right, looking at this diagram. First, name all corresponding angles. Remember, when you're naming corresponding angles, you're taking the two lines, smashing them together. So name me, I'm going to write it out here so that, maybe I won't. I'm going to write it out here so I got space. If I smash those two lines together, name me a pair of corresponding angles.
1 and 5.
1 and 5. So we know angle 1 is congruent to angle 5. Give me another pair of corresponding angles. Angle 2 is congruent to angle 6. Another pair. 3 and 7. So angle 3 has to be congruent to angle 7. And the last pair, 4 and 8. Angle 4 congruent to angle 8. Remember, with corresponding angles, you have 4 pairs of them when you have the whole picture like this. So there's more of them than anything else. All the others will only have 2 pairs. Chris, you might want to, at some point, just get online, watch this video. I'll try to make sure I get it downloaded pretty quick today so that you can get on there and see all of it. About letter B. If I just follow along maybe while you're in here so you catch some of it. Alternate interior angles. Name me a pair of alternate interior angles. Remember, alternate interior should form a what when you trace them? A Z or a N. They got to be interior angles, so inside, and they're on opposite corners on the inside. 2 and 7. If I trace those two, 2, 7, they form a Z, sort of. So angle 2, and we knew that alternate interior angles had to be congruent to each other. What's the other pair of alternate interior angles? 5 and 4, 4 and 5, whichever way you want to say it. So we know that they're congruent. Alternate exterior angles. Opposite corners on the outside. And again, our theorem that we just went over a few minutes ago told us that they had to be the same as each other, or congruent. So angle 1 is congruent to angle 8. What's the other pair? Good. Angle 3 is congruent to angle 6. Remember, for all those, there'll be 2 pairs. The only one that's got more than that are the corresponding angles, the ones where you shove the lines together and get them overlap each other. And letter D. Again, I put this one last because it's different than all the rest of them. This time, when we're dealing with consecutive interior angles, instead of being congruent to each other, what are they going to be to each other? Supplementary. They add up to 180. So when I write this, give me a pair of consecutive interior angles. So angle 2 is supplementary to angle 5. And angle 4 is supplementary to angle 7. What's it mean to be supplementary again? They add up to equal 180. So this angle, angle 2 right there, plus this angle, anytime you have parallel lines in a transversal, those 2 angles must add up to be 180. Now that's going to be important down the road. If I gave you a figure like this, what kind of shape is that? Probably learned this at some point in your mathematical careers.
A rectangle.
Could be a rectangle, but we don't have enough information to say for sure it's a rectangle. Parallelogram, very good. It's a parallelogram. What do you know about these sides? They're parallel. What do you know about these sides? They're parallel. Look at these 2 angles right here. This one and that one. Which one of these 4 are they to each other? They're consecutive interior angles. And it's sort of hard to look at it. This is what Sierra was having trouble with earlier. It's sort of hard to look at it in a picture like that, right? So if I did this, if I drew that line, that's our transversal. These are our 2 parallel lines. If I could draw them. These 2 angles are here and here, just sort of extending these lines out farther. Then you can tell that they're consecutive interior. Well, what has to be true about these 2 angles? They have to add up to be 180. They're supplementary. What has to be true about these 2 angles over here? They have to be supplementary. What has to be true about these 2 angles? They have to be supplementary again. So consecutive angles in a parallelogram, we'll learn that later on in the year. You don't have to know it now. But we're going to use that consecutive interior angle stuff on it all the time. All right, draw this. This might be real helpful next class. I'll see you guys again next Tuesday. Because there might be a quiz when you walk through the door, and it might look real similar to this. Oh, these got spaces in them because there should be angle symbols in here. I'm not sure why the 85 got dropped down to there. We can move it up there if you want. I think it drops down every time I switch it. All right, when you're doing a problem like this one, please make sure, if we're looking at angle 1, I come out here and I mark angle 1, it's 78 degrees, and we want to deal with angle 1, then split off the picture and only use 3 of the lines and not all 4. I know that every one of you thinks that Oh, I can do it, I don't have to draw that off. I'm telling you, you're gonna mess up if you don't do it the way that I'm telling you right now. So if we have angle 1, let's find angle 2, 3, 4, 5, the early ones first. So I'm gonna split this off. If I want angle 1 in my picture and I want angle 3 in my picture, then I gotta use this line as my 2 parallel lines, and this as the transversal. So I'm just gonna come up here, and my picture might not look exactly like it. So we got these 2 lines, this is our transversal. Doesn't have to be exactly the same, just so you know what you're dealing with. That's angle 1, that's angle 2, 3, 4, 5's right there. And we know that these 2 lines are parallel. First, what do you know about angle 1 and angle 2? They're supplementary, so they have to add up to be 180. So can we find angle 2 pretty easy? 180 minus 78 is what? 102, good. Now let's worry about jumping over here. We know this is 78, we know this is 102. What kind of angles are 2 and 3 to each other? We just got done talking about them. Consecutive interior, so they have to add up to how much? 180. So what's angle 3 going to be? 78. I write it in. 78. What do you know about angle 3 and angle 5? Try to make this as easy as possible on yourself. Pick out stuff like angle 3 and angle 5. They're vertical, so they have to be congruent. So what's angle 5? Now, we didn't do angle 4 yet. Let's do what kind of angles are 2 and 4 to each other? Just to use something different. They're congruent to each other because if I shove the 2 lines together, they overlap. What kind of angles are those? Corresponding. So if this is 102, what's this one out here? 102. Now we know all those angles. How are we going to find all these others down here? Instead of using this as our transversal, line D, what would we want to use as our transversal? Line E. So I'm going to go back up here. And please do this. I draw them off. We're going to put this line in as our transversal. Because if you don't, I swear to you, you will get confused and you will mess things up. 6, 7, 8, 9, 10, 11, confusing myself, 12, 13. You might want to draw your picture to look a little better than mine so that you don't confuse yourself like I just did. Now we knew that angle 6 was how much? So we write that in there. Now can we find all the rest of these angles? Pick me one. Let's find, we know that this one's 85. 8's 85. Let's just run through this sort of quick. Give me another one we know. 11's 85 because those were alternate interior angles, right? So they form that Z. 13 and 11 are vertical angles, so that's 85. 9 is 95 because 6 and 9 have to add up to 180. 11 and 9 also have to add up to 180. 12 is 95. 10 is 95. Did we find all the angles?
Yes.
Now, if you split it off like that, is it real difficult? If you don't, if you think, oh, I can do this without doing it, I guarantee about half of you will get confused somewhere and you'll put like a 78 down here. And it doesn't belong down there. It doesn't go that way. All right, draw this. I'll give you a second to draw it. This is a sort of an important problem. We're going to talk about it And this is called a crook problem. I'm not sure what this book calls it, but I call it a crook problem. Why would I call it a crook problem? What's true about the transversal? Crooked, isn't it? Crooked. On this crook problem, what you're going to do, anytime you see something like this, we can't solve it the normal way. We can't say, oh, we have alternate interior, alternate exterior. So you're going to do something special every single time you see something like this. And what we're going to do first is we're just going to draw an extra line. My pen will draw an extra line that goes right through the crook. So you just want to draw this line first. And what we're going to do with that line is we're going to say it's parallel to the other two lines. Now, usually you can't just make up stuff and put stuff in the picture just because it helps you. This we can, because how many lines in the world are going to go through point H right there and also be parallel to these other two lines? One. There's only one in the world. So if I draw my line in here, you draw your line on your paper, is it going to be a different line?
No.
It's the exact same line. Everybody's got the exact same line because that's the only line that fits what we wanted it to fit there. Now, once I have that, I'm going to do this. I'm going to split off the top two lines, the one we drew, and line AB up top here, and I'm going to use this as our transversal. This angle right here is 40 degrees. Can we find all these other angles in? Tell me what this angle over here is. This angle? 140. This angle? This angle? 140. You could use alternate interior angles. You could use consecutive interior angles. What's this angle? Now, what we're looking for is this whole thing right here. Well, we didn't even have to find all those. What's the only one of those that we actually needed? That one right there. And we know that it is 40. Now, is that angle H? It's part of angle H. Don't say it's half of it because we're not sure about that, but it's part of it. If we find this part, then we'll know that whole crooked angle there, and not a crooked angle, but we'll know that whole crook. Right, so once you find those two, you add them together. Now the way we're going to find the other part is by using these two lines as our transversal, and the line that goes out this way is these two lines is our parallel lines, and the line that goes out this way is our transversal. What do we know about this angle right here? Can we find all of these angles? Yeah, but to save time, do we want to know all of them? So I'm going to number them here real quick. 1, 2, 3, 4, 5. Which one do we actually care about? All we care about is angle 2 right there. So if this angle's 70, look at what kind of angles that angle and the one we're trying to find are. What do they form together? A Z. So what kind of angles are they? That's true. Give me something else. Alternate interior angles, right? They form a Z or an N. They're alternate interior angles. And you know that alternate interior angles have to be congruent, so it has to be 70. Now my picture doesn't look anything like it, but what's all of this angle then? 110. So that's just sort of a crazy problem. And you can actually, if you have an angle, what this is used for in engineering or surveying a lot of times is they'll have an angle somewhere, maybe at the corner of a property or something, and it might not be exactly a right angle. Well, then they'll put parallel lines in there crossing that angle and shoot right through here, and they'll be able to find that angle to see, all right, it's not 90 degrees, but it's 110 or 50 or whatever it happens to be. That's a crook problem. All right, this is your assignment. If you hurry up and get this out, I'll start working problems on the board. So open up your books to page 136. This will help Jason out to make sure that he doesn't forget it, because Mr. Eversole is going to work part of it for
I
him.
can't risk it in him tonight, I want to get.
You told me that yesterday when I told you the same thing. And then you missed today's assignment anyway.